Compound interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. There are two formulas for compound interest, which is compound amount and interest. P is principal, is amount of money deposited, borrowed, or invested. Next is annuity. Annuity divided by two categories, which were future value and present value. Annuity also got two formulas, the future value of an annuity and the present value of an annuity. For part A question 1, we need to calculate future value of the investment. So first, we need to do first 10 years. I equals K over M, 0.055 over 3, and N equals MT. 3 times 10, we got 30. We use formula SP1 plus I and 25,000 I plus 0.55 over 3 and 30. And we got the answer for 33,116.03. And next, we're going to calculate for next 5 years. I equals to K over M, 0.07 over 6, N equals to MT, M6, T is 5, and we got 30. And we use the same formula, SP1 plus I and P as 40,116.03, 1 plus 0.07 over 3 and 30. And we got the answer 61,060.73. For question B, we need to calculate the down payment. So down payment equals to 450,000 times 10 over 100, which is 10%. And the answer is 45,000. For question B2, we need to calculate the invested money for down payment. So 0.0653 over 2, the answer 0.03265. N equals to MT 2 times 10, and then we use the answer S equals P1 plus I, and S is 45,000 equals P 1 plus 0.03265, N is 20. P equals to 45,000 over 1.901354021. P equals to 23,067.34.
This is all the information in question 2A, so you must put it on solution, where you need to find R. First of all, for 3 years early, you need to use formula S equal to P1 plus I, the power of N, where 7,000, 1 plus 0.05 over 12, the power of 36. When you calculate, you will got the answer 8130.31. Actually, S equal to B2. So, in the next 2 years, you still use the same formula compound interest, where 95060 equal 8130.31, 1 plus R% over 4 the power of 8. You need to move the 8130.31 into left side, where it's divided by 9560. After you divided, you got the answer is 1.175846923. Next, you move the power of 8 into left side. You will get the answer is 1.0204544977. Next, you also move 1 into left side, so it will minus with the left, and you will get 0.020459477747. Next, you move 4 into left side, become multiple with a left side answer, and final answer, you will get R equal 8.18%.
For the question 2B, you also need to put all the information into solution. First, we want to find term, where we use formula compound interest. In the formula, 80360 equals 65, 000, 1 plus 0.0425 divided 12 the power of n. You put the left into right, but move 65300 into left, divided 80360, and you get 2009 over 162525. After that, you change the power of n into irrational number, and multiple loan right side and left side. After that, n equal a loan 2009/1625 divided loan 1 plus 0.0425 over 12. Final answer for n, you get 60. For find term, you use formula n equal m multiple t, where t equals 60 over 12. Final answer is t equal to 5. Second, you need to find interest. You use formula I equal S minus P, where equal 80360 minus 65300. Final answer, you will get 15360.
So, hi guys, this is my question. Part B, question 1. So, R equal to 800, M equal to 2, T equal to 12.5, K equal to 0.054. So, we need to find I first. I is K divided by M. So, K is 0.054 and M is 2. So, we get the I. Next, we find N. N is M multiple T, so 12.5 multiple 2, and we got 25. So first we write the formula is future value, and then we put all of that into the formula. So 800 bracket 1 minus 0.054 divided by 2 and bracket square 25 minus 1, and then we divided all of that with 0.054 divided by 2. So we bring the down part 0.054 divided by 2 to the front, and then we count that, and we got for the first one, and then we count the bracket and we got that 0.9465, and then we multiple both of that and we get the answer. K equal to 0.044 and N equal to 12 and T equal to 6 and R equal to 237.42. So first of all, we need to find I. I is equal to K divided by M. So I equal to 0.044 divided by 12, and we got that I. So next we need to find N. M equal to MT. So 12 multiple 6 and we got 72. 72 minus 50. Why? Because the question said after paying 50th payment. So we need to minus it with 50. And then we got 22. So like always, we put formula first and then we put all of that to the formula. So 237.42 bracket 1 minus 0.044 divided by 12 square 22 minus 1, and we divided all of that with 0.044 divided 12. So we count the front and we got 712260 divided by 12, and then we count the back and we got 0.0838, and then we multiple both of that and we got the answer.
Part B, question 2, number 1, calculate the number of equal payments required. So we have to find n. Number 2, if Nelda failed to pay the first 10 monthly payment, how much should she pay on the 11th payment to settle all the outstanding error? So n must equal to 11. Number 1, we have to find I first. I equal K over M equals 0.045 over 12. N equal mg. So the question didn't give the t, so we have to find n. So we use the formula of A equal R 1 minus 1 plus power negative n over I. So we insert all these numbers into the formula. Then we got RM 240,000, RM 3146.88 in the bracket of this one. Then we brought this bracket into the left. Then the RM 240,000 into the right. So then we over with 3146.88. Then we multiply with 0.045 over 12. And then the answer will be minus by 1. So we got negative 0.714000244. And then we have to find the power negative n. So we use the formula of in. So we insert all this number again. Then we over with it. Then we got negative n equal negative 90. But we have to find n, just n. So n must equal to 90. That's the final answer. Next, number 2. Find outstanding error on the 11 monthly payment. So we have to find I first. I equal K over M equal 0.045 over 12. N equal MT or equal 11. S. So we use the formula of S equal R 1 plus I power N minus 1 over I. So then we insert all these numbers. Then we calculate this one first, because that's the important thing, and then we multiply with 3146.88. Then the final answer will be 35272.08. In conclusion, the fundamental similarity lies in their reliance on the interaction of money, time, and interest rates. Both concepts illustrate how financial resources can grow or be managed efficiently using time and compounding principle.